we continue our discussion of thermodynamics by talking about the first law of thermodynamics. Now remember, we already discussed the 0th law of thermodynamics in earlier videos. So this is the second of 3 laws of thermodynamics, but it's called the first law because the first and the second law were discovered before the 0th law. So the first law of thermodynamics just states that the change in internal energy of a system is in some object or some collection of objects, equals the net heat transfer into the system minus the work done by the system. So the change in internal energy, U is the internal energy of the system. You can change that internal energy 2 ways. You can either add heat to the system, basically transferring energy to the system via heat, or the system can do work. Again, an expanding balloon, for instance, a force is applied through some distance, work is being done, that would take energy from the system. So work here is subtracted because it's work done by the system. In some textbooks, especially if you're using alternate textbooks as another reference, another resource, you might see a plus sign here instead of a minus sign. If you read carefully, if you see a plus sign here, that book will say work done on the system. So you can increase delta U by adding heat to the system or by doing work on the system. But if the system itself is doing work done by the system, then you lose internal energy, right? The energy has to come from somewhere. So if the system is doing work, it has to lose energy. Now the internal energy, U of the system, is just the sum of all the kinetic and potential energies of all the atoms and molecules in that system. So when we talk about ideal gases, they're just basically the kinetic energies of the objects bouncing around. But in the case of gasoline, right, gasoline is a molecule, and that molecule actually stores energy. If you can burn gasoline to release additional energy. So the internal energy of a system is the sum of all the kinetic and potential energies of its atoms and molecules. Now the first law of thermodynamics is very important because what it basically says is a system can do work, and that work comes from the internal energy of the system. I can use a system with energy to do something. So a hot gas can be used to expand a hot gas in a piston to push my car forward. So this relationship, this is why it's called thermodynamics. Thermo being, again, temperature, dynamics being motion. So it's the motion from things with heat. So we can use our understanding of thermodynamics to create engines, right? This was a huge boon for the Industrial Revolution when we realized we could create the steam engine, and then later gasoline and other types of engines, diesel engines and so on. It's a way of getting work out of a system.